Lambda Logistics Group, a private consulting firm comprised of engineering and policy analysis students from TU Delft, presents a simulation study of Heerema's Agers project logistics. Our international team is made up of Onno from the Netherlands, Marc from Canada, Rachel from the United States, and Mahtab from Iran. The Aegir is Heerema's brand new deep water construction vessel. In January of this year, it set sail from China to the Netherlands to begin projects worldwide. Among other features, the Aegir has 2 knuckle boom cranes, a 48 megawatt total main power plant, a pipe lay tower for J-lay and reeling, and deep water lowering of up to 3,500 meters deep. The logistical challenges faced by the Aegir lie in the complexity of the new reel concept and the fact that the Aegir will complete pipeline projects worldwide. For this study, the focus was on selecting an optimal choice of transporters to move reels and structures to and from the Aegir. The transporters available are small and large barges and HLVs, otherwise known as heavy lifting vessels. Each vessel has certain speeds and carrying capacities, but also associated costs per day of use. Therefore, we focused on testing combinations of transporters to minimize total time to complete all projects and total project costs, which included the cost of transporters, the structure and spool base yards, and Aegir costs. A model was made in Arena, simulating all processes on the Aegir and showing an animation of project work worldwide. The animation served as both a useful visual tool for the user to see how project work was being completed, but also as a validation measure, as we were able to see whether or not all the required pipelines were completed. The model was broken into 3 blocks. One for the spool base yard, where new reels are spooled and welded. One for the structure yard, where built structures are transported. One for all processes on the Aegir. And finally, a block for initiation that allows the user to set different transporter combinations. A key feature of the Aegir that is depicted in the model is the exchangeable reel concept. The Aegir can carry 3 reels at maximum, 2 being full and 1 empty. Empty reels can be shifted to an empty position while a barge brings the next full reel. The model animates when a reel is empty and also the process of pipe laying. After numerous simulations and tests, several combinations of transport vessels were chosen to compare for total time and cost. First, only small barges were placed in each region, ranging from 1 to 5. Second, only large barges were placed in each region, again ranging from 1 to 5. This decision was made in order to see if there's a relationship between adding more barges and optimal efficiency. Finally, several combinations were chosen of large and small barges plus HLVs. Out of the 19 runs, 2 seemed best in terms of total time and total cost. A run with 3 small barges and 1 HLV in each region demonstrated the lowest time and also came with a relatively low associated cost. Additionally, the run with just 3 small barges placed in each region also came at a low total project time and low cost. Based on the combination chosen, some interesting conclusions can be drawn. As shown by the graph, merely increasing the number of transporters only decreases total time to a point. Then the process becomes inefficient, as shown by the leveling out of the graph. Finally, the simulation also demonstrated that there may be a relationship between total cost and time, perhaps due to the fact that A-gear costs will increase with an increase in project time. Based on the study, several conclusions can be made. Using 3 small barges combined with HLVs seems optimal in terms of time and cost. However, in all of the simulation runs, there seems to be an optimal number of transporters. Simply adding more does not necessarily decrease the project time. Secondly, there may be a correlation between time and costs, which is relevant when considering the option of just adding more transporters. Finally, we would like to thank all those who supported us during the completion of the project: Heerema Marine Contractors, Ms. Noortje Sturm, Professor Sek, and Delft University of Technology, Faculty of Technology, Policy, and Management.